Welcome to episode 17 of CipherVibe's end-to-end cloud security architecture course. Infrastructure as code turns cloud architecture into versioned, repeatable changes. Its security advantage is the ability to prevent unsafe configurations before they create resources, not merely detect them afterward. We will connect its purpose, design boundaries, implementation path, failure modes, and evidence of effectiveness. Every cloud security layer relies on the ones around it. IAC Security connects design standards to pipelines, cloud guardrails, posture management, identity, network, data, and logging. A template is a security-critical artifact because it can recreate a risky state repeatedly. Treat the architecture as a chain. A trusted identity requests an action, a policy makes a decision, a workload or data service enforces it, and telemetry records enough context to investigate later. The first building block is define secure templates and modules. Create reusable modules and templates that apply encryption, logging, private networking, tagging, least privilege, and policy boundaries by default. Version them, document permitted inputs, and make unsafe exceptions explicit so teams do not rebuild critical controls from scratch. The second building block is scan early and in context. Use linters and scanners such as checkoff, tflint, or terrascan to find misconfigurations, then supplement them with organization-specific policy as code. Run fast checks locally and enforce high-confidence gates in pull requests or release pipelines with clear remediation guidance. The third building block is protect state and credentials. Store state in protected, encrypted remote backends with least privilege access, locking, retention, and audit logs. Use short-lived deployment identities and prevent secrets from entering configuration, state, plans, or build logs whenever a managed reference is available. The fourth building block is verify deployed reality. Review plans before apply, require approvals for high-impact changes, detect drift, and reevaluate the deployed resource with posture or configuration controls. Fix the source template as well as the live resource so the next deployment does not recreate the same unsafe condition. Use this reference pattern. Begin with an explicit policy that describes the permitted outcome. Enforce that policy at the closest reliable control point. Route decision and activity evidence to protected storage. Then give an accountable team a tested path to review exceptions, correct drift, and respond to violations. The reference IAC pattern makes secure modules the default, scans proposed changes before merge, protects state and deploy credentials, and validates the deployed result continuously. Implement this layer in a sequence that preserves evidence and limits blast radius. First, inventory repositories, modules, state backends, and deployment identities second, publish secure modules for common cloud patterns third, add local and pull request scanning with clear policy ownership fourth, harden state access and replace static deploy credentials fifth, connect drift and post-deploy findings back to source remediation prefer pilots with a named owner and rollback plan over an unmeasured organization-wide switch. The best rollout is one where a normal workflow succeeds, an unsafe path fails closed, and the team can explain the decision from logs rather than intuition. Security architecture fails most often through assumptions, not dramatic movie-style attacks. First, treating a scanner passing score as a design review second, letting state files expose credentials or sensitive topology third, applying changes directly from personal administrator accounts fourth, fixing a live resource while leaving the template unsafe. A configuration screen is not assurance. Collect evidence that the intended control applies to the correct scope and that violations become visible. First, test a deliberately unsafe template in a non-production repository second, measure secure module adoption and policy coverage third, review state access and deploy role activity fourth. Verify drift detection finds a safe simulated console change test both normal activity and a safe negative case in an authorized environment. Record the expected decision, the evidence location, the owner who reviews exceptions, and the rollback method. Repeat after platform changes, new integrations, or major shifts in business use. For a practical exercise, create a fictional Terraform module standard for a private storage service with encryption, logging, and public access prevention. Use synthetic information or an environment you own or are explicitly authorized to administer. Deliver a one-page diagram, a concise control statement, a list of expected audit events, and one test for an allowed path plus one test for a denied path. This artifact is more valuable than a screenshot because it explains the reasoning behind the configuration. Before scaling this layer, ask 5 review questions. Which assets, identities, or environments are in scope? Who owns the desired state and exception decisions? Which enforcement point can reliably apply the rule? Which records prove the decision and retain enough context for an investigation? And how can the organization revoke access, contain impact, or roll back safely when a control fails? Good architecture makes these answers explicit and testable. The key lesson is that infrastructure as code security becomes dependable only when design, policy, enforcement, evidence, and ownership move together. Document the decisions you make, remove permissions and exposure that do not support a real requirement, and rehearse the paths that matter before an incident forces the lesson. Continue through the next episode to connect this control layer to the rest of the CipherVibe cloud security architecture.